Hello students, today we will discuss areas related to circles. It's a 10th class topic, but as a physics teacher I know there is a lot of use in circular motion chapter. So some things what we find it in related to circles we use a lot while doing problems of circular motion. So I am dividing my lecture into 5 parts: terms related to circle, unit conversions related to circle, finding length of arc, finding area of sector, finding area of segment. This obviously covers the required course of 10th class also. So let me draw a circle first. So this is a circle. We define circle as a locus of points. We go on, put some points, point. All are equidistant from this point, and this point is called center. This locus of points which we span like this is a circle, and each point should be at same distance, and this we call it as radius. Generally radius is represented by symbol R, center is represented by letter O. If at all I extend this radius further this side also as a straight line, then this total one is called diameter. From this we can understand that radius is equal to half of the diameter. Everyone knows it, but once we are talking about terms we shouldn't talk everything. Next, if a line is there which is joining 2 points of a circle but not passing through center like diameter, is called chord. The portion spanned by this chord inside is called minor segment. The small one. The other portion which is spanned by this chord, the other side, the bigger one, is called major segment. This is minor segment, that is called major segment. Taking this center, if at all we have a chord kind of thing but it is extended like this beyond it is touching 2 points of a circle and it is extended, it's called secant. If at all at only one point a line touches and goes, that line is called tangent. Tangent is a line which touches only one point of the circle. If you try to make any other line, it will touch other points also. It has to touch only one point. A perpendicular drawn to the tangent 90 degrees is called normal. Normal can be called as an extended radius. Normal can be called as an extended radius. So once again, circle is a locus. Locus means once you join all the points, whatever you get, that is locus. Locus of all points which are equidistant from one point called center. That center is represented by letter O. From center to any point of the circle if you draw, that is called radius R. Double of radius along a straight line is called diameter. Diameter touches 2 points of circle and passes through center. Chord touches 2 points of a circle but don't pass through center. Extended chord is called secant. The line which is touching only one point of circle is called tangent. And line perpendicular to the tangent is called normal. Normal can be taken as extended radius. That means radius and tangent are always perpendicular in a circle. Next, the chord whatever we have drawn, it spans some area. The bigger area is called major segment. The smaller portion of area is called minor segment. Now, as you understood these terms, I take small portion, like when we are eating a pizza, we purchase a pizza and we take a small portion of pizza, 6 pieces they make, 8 pieces they make. So that piece of pizza, one single piece of pizza what you have taken is called sector, and the small piece is called minor sector. And the leftover portion, for example, a pizza has been cut into 6 pieces, you have taken 1 piece, remaining 5 pieces leftover is called major sector. The small one is called minor sector, the big one is called major sector, and this outer portion of the pizza before removing the portion is called arc. Again, smaller arc, minor arc, the other portion is called major arc. So the important terms is how to calculate arc of a length of arc, area of sector, area of segment. These are three things which are to be known by a student. That will be coming as a second part of the lecture. We will do conversions, then we go to that. So first we are talking about terms. They are the important terms in a circle. Multiple times you see it and try to understand each term. Hey students, you know in physics unit conversions is there. Some people measure length in centimeters, some people measure in meters, some people measure in kilometers, like that, inches, yards, foot, like that. So SI system recognizes meter as standard version. That only angles can be measured in number of rotations or half rotation, full rotation, 2 rotations, 3 rotations, like that, or number degrees, 10 degrees, 20 degrees, 40 degrees, 280 degrees, 360 degrees, 720 degrees, like that, or radians. And radian is accepted as standard version. Radian is defined as the angle subtended by arc of circle at center of circle whose length equals radius of circle. I have written it point wise, but you have to read it completely. Suppose I have an arc, and arc is a portion of one circle. So for example, this is a circle. I take some portion of arc. If I spread one thread on this arc and I stretch the thread and I measure the length, that length should exactly come equal to radius of the circle. That means, for example, this spread by 11 centimeters. Then we have to draw a circle of 11 centimeter radius. This is arc length. This is radius. Whenever we make arc length is equal to radius, that spans some angle at the center of the circle. That angle is 1 radian. You may ask, sir, you have drawn one circle, we will draw another circle, then how? Okay, you draw a small circle, then me. Suppose you have drawn a circle of radius 8 centimeters. Then you are not supposed to take whatever length, 11 centimeters length. You take, because your radius is 8, whose length is equal to radius of circle. So you have taken 8 centimeters length, you have to go along the circle 8 centimeters. And this is 8 centimeters. And this radius is 8 centimeters. 8 cm this radius, 8 cm this radius, this length is also 8 cm, then this angle is 1 radian. But there can be one mistake that can be made. For example, 8 centimeters, 8 centimeters and 8 centimeters, 8, 8, 8. If you create one equilateral triangle by drawing straight lines, then this angle will be 60 degrees, which is not equal to radians. Radian comes out to be near about 58 degrees, because we are not allowed to go straight from one point to other point. You have to go along the curve. So along the curve, when you go 8 centimeters, this radius and this radius are 8 centimeters, the angle span inside is 1 radian, which will be near about 58 degrees approximate. And if you go 8 centimeters like this, 8 centimeters, and directly draw a straight line 8 centimeters, that becomes an equilateral triangle, and this angle comes out to be 60 degrees, which is not 1 radian. Now, using this definition, length of arc and radius 11 cm by 11 cm, that is 111 cm is length of arc, by another 11 cm is equal to radius. If both are equal, then we get angle in radian mode. So this 11 you can simply we can remove it, because you can take any circle of any size. Only thing is length and radius should be equal. Then theta will be 1 radian. So general formula of finding angle is length of arc by radius is equal to angle in radian. Length of arc by radius is equal to angle in radian, or length of arc is equal to radius times angle in radian. Angle in radian. So any one of the formula you can remember it. Better to remember in word form. Length of arc by radius is equal to angle in radian form. But you should know how to convert any angle into radian. That is the second part of my lecture called conversions. So standard angle accepted by SI system International is, you have to measure angle in radians. Radian is defined as the angle subtended by arc of circle at center of circle whose length is equal to radius of circle. The arc length should be equal to radius of the circle. Then angle subtended at the center is called 1 radian. We'll quickly do 3 problems so that you get more connection. This radius is 10 centimeters. This radius is 6 centimeters. This radius is 12 centimeters. Don't scale it, just approximately I told. And for example, I go up to here such that this length is 3 cm. I go up to here such that this length is 13 cm. I go up to here such that this length is 18 cm. Now, what is this angle in radian? Theta 1. What is this angle in radian? Theta 2. What is this angle in radian? Theta 3 is our question. As we know formula, theta in radian is length of arc by radius. So, let us do the first angle. In radians we will find it out. Theta 1, length of arc, 3 centimeters by 10 centimeters, 3 cm by 10 cm. 0.3 radians. Over. Now, that one, theta 2, length of arc, 13 cm. Both must be in same unit, cm, 6 cm. Cross, cancel. 13 by 6 radians. So simple as such. This is 18 by 12. 6 tables, 6 2s are, 6 3s are. 1.5 radians. This angle is 1.5 radians. So simple, so quickly you can get it. Just length of arc you have to divide with radius. See students, this is a problem and there is a trouble here. The trouble is, this is radius is 10 centimeters. This angle is 30 degrees. This is also 10 centimeters obviously. We want length of arc. As we know that theta is equal to L by R, length of arc by radius. So obviously length should be cross multiplication of this. So length should be equal to R times of theta. Length we want. This length of arc we want. So R 10 centimeters into 30 degrees. If you do it, this is not going to give you correct answer. So 10 into 30 is 300. Is it centimeters? Is it degrees? Whatever you want, whatever you get it, that is wrong answer. So because the angle is not in radian mode, angle is in degrees mode. So every student before doing a calculation, you have to confirm whether you know conversions or not and the angle is in radian mode or not. If somebody they are told that this angle is pi by 6 radians, then you can do it. Okay, no problem. Pi by 6 radians if they give it, then length of arc is equal to radius 10 centimeters into pi by 6. So it is 10 pi by 6. Length of arc is in centimeters, we write it. But again there is a problem here. This is in SI system, this is not in SI system. In SI system, length is measured in meters. So 10 centimeters should be written in meters. 1.1 meters into pi by 6. This is the proper way of doing it. Then whatever answer you get. So 0.1 into pi, that is nothing but 1 by 10. So pi by 60 meters. Because in SI system, meters is recognized, centimeters is not recognized. So this is the small procedure. This is the trouble what you are going to face in future. So everything you have to maintain in SI system. So second portion, conversions we are doing. Then you will understand many other things. Yes, students. One complete circulation or rotation will give you degrees wise 360 degrees. That is equal to 2 pi radians. You have to by heart this unit conversion. So first part is over, terms are over. Now we are going into conversion. I told what are the terms, and most important term is radian. What is a radian? Definition you have to learn it. Coming to conversions, these are the conversions. So mainly there are 6 conversions: rotations to radians, rotations to degrees, degrees to radians, degrees to rotations, radians to degrees, radians to rotations. These are the simple calculations which we are going to get it in future. So maximum possible things. Actually you can go on give many questions, but these are the 6 possible things. Should be able to convert this into this or this into this, like that, interconversions. So 3 rotations is equal to dash radians. This kind of question whenever you come, you link rotations and radians. Rotation and radian. 1 rotation is equal to 2 pi radians. This is the standard. Now 3 rotations is how many radians? 3 rotations is equal to how much? That you can put it as x. Cross multiplication method. X into 1 is equal to 2 pi into 3. So x is equal to 2 pi into 3 by 1. Bring this 1 down. So this 1 rotation and this 3 rotations, rot cancels. So 2 3s are 6. X is equal to 6 pi. So this is to be filled up with 6 pi. Next, degrees to radians. How to do it? Let us take some little easier question. 90 degrees is how many radians? Again, degrees and radians to be connected. 360 degrees is 2 pi radians. 90 degrees is equal to x radians. Cross multiply. 360 into x is equal to 2 pi into 90. This is in degrees, this is in degrees. Bring this down. X is equal to 2 pi by 360 into 90. Both are in degrees. 0 0 cut. 9 1s are 9 4s are 2 1s are 2 2s are. X is equal to pi by 2 radians. So this is pi by 2. This kind of conversion should be able to do it. Radians and degrees. What is the link? 2 pi radians is equal to 360 degrees. Accordingly you will get it. But one procedure we can by heart and remember forever is this one only. 2 pi by 360 which comes always common. 2 pi and when the denominator 360 will come common into whatever angle is given, that you write in degrees. Because 360 is also degrees, you write 60 degrees, 70 degrees, 90 degrees, whatever you write it. Automatically you will get the answer in radians. So easier trick which is going to be troublesome to you on regular basis you have to do it is, they are given 30 degrees. How many radians? 30 into 2 pi by 360. 2 pi by 360. You will get it in 30 degrees becomes 30 this radians. So 0 0 cut. 2 1s are 2 18s are 3 1s are 3 9s are. Sorry, 3 6 are. Pi by 6 radians. Pi by 6 radians. So quickly you will get the answers like this. Okay, students, now we will find length of arc. Already I told you the standard formula from definition of radian in the first portion term when I was defining the terms. Theta in radian is equal to length of arc by radius. So theta in radian is equal to L by R. Cross multiply. L is equal to R times of theta. L and R should be in the same unit, and theta should be in the radian mode. But if at all you don't know theta in radian mode and you know theta in degrees, what to do? I just now told you in the conversions that theta in degrees multiply with 2 pi by 360, or even you can multiply with 2 pi by 180, because 2 pi 2 and 360 gets cancelled. That you multiply it. For example, I want length of this arc whose radius is 8 centimeters. So L1 is equal to R theta. R is 8 centimeters. Final answer comes in centimeters if at all you don't convert it. If you convert it, there is no problem. Then 30 degrees, because we don't have angle in radians, you have to write 30 into this 2 pi by 360. 2 pi by 360. 0 0 gets cancelled. 3 1s are 3 12s are. 2 1s are 2 6s are. Pi by 6. So 8 pi by 6. So further you can cancel it. 3s are 4s are. 4 by 3 pi. 4 by 3 pi is 22 by 7. So or you can write it as 3.14. 22 into 4 is 88, 7 3s are 21. So that value, whatever you get it, you cancel it and get the answer. That will be length of this arc, if at all this radius is 8 centimeters. Similarly, I want length L2. L2 is what? Angle and radius. Radius is 10 centimeters. This is here final answer comes in centimeters because you are not converted the unit. Actually, you have to convert it, but even if you don't convert it, these two should be in the same unit. This cannot be in inches and this cannot be in meters. Radius and length should be along the same units. 10 centimeters into angle 60 degrees. 60 degrees into, instead of writing 2 pi by 360, 2 and 1, 360 gets cancelled by 180. So pi by 180, more easier thing. 0, 0 gets cancelled, degrees gets cancelled. 6 1s are, 6 3s are. So 10 centimeters by 3, this comes down, pi. Pi is 22 by 7. 210 by 7 3s are 21 centimeters. Answer comes in centimeters. In this way you can find length of the arc, but you have to write that pi value 22 by 7 or 3.14 and get the answers. In this way we can find length of arc. If you know length of arc and if you know radius, divide them to get angle. And the angle comes in radian mode, direct. That if you want to convert into degrees, that conversion table I told, one circulation is equal to, or one rotation is equal to 2 pi radians or is equal to 360 degrees. Once you get in radians, you should be able to convert into degrees. Once you get degrees, you should be able to convert into radians. Rotations to radians, everything you should be able to do it. This is the way we can find length of arc. Okay, students, we are coming into the fourth portion, finding area of a sector. So if you have a circle, from that you chop out some small portion, then this is called minor sector or sector itself. Once it is been told sector, it is understood it is minor sector, major sector. So I removed this portion. Like I told you, you have a pizza, in that one portion you have removed it. Now how to find area of minor sector and area of major sector? Let this angle be theta. Then this total angle will be 360 minus theta in terms of degrees. 360 minus theta degrees. If at all you tell in degrees, you have, if you have in rabbit and telling radius, this is theta radians, then this is 2 pi minus theta radians, where theta also should be in radians. Okay then, now area of this sector, how to find? For full circle, area is pi r square. Part of circle, that is sector, area is x. For full circle, angle is 360 degrees. For part of circle, angle is theta degrees. Cross multiply. 360 degrees into x is equal to pi r square into theta in degrees. So cross multiply. X is equal to pi r square theta by 360. Both of them must be in degrees, which is also equal to pi r square times of, if at all I want to put in radians, theta in radians divided by 360 degrees is 2 pi. So this pi and this pi gets cancel. 1 by 2 half r square theta in radian, half r square theta in radian. So there are two formulas came out for us. So area of minor sector is pi r square, which is the full area of the circle, into the portion, that is how many degrees it has spanned compared to the total 360 degrees. That way you can date it. That is the one way of getting. The other way is half r square theta in radian. If at all you know how to convert degrees into radians, then that way you can do it. So both are same. Whichever way you feel comfortable, that you can use it. Let us do a problem. For example, this minor sector is some 60 degrees. This portion area is area of the minor segment is equal to pi r square into 60 degrees by 360 degrees. 61s are 66 are 6 are 36. So pi r square by 6, 1/6 portion of the circle. 1/6 portion of the circle. Sometimes you want, this is minor area, minor sector. Now you want major sector. Major sector. That is equal to full circle area pi r square minus minor sector. Major sector is equal to full circle area minus minor sector. This is pi r square minus this one, whatever you got, pi r square by 6. So 6 ones are 6 minus this. So 5 by 6. 6 ones are 6, pi r square minus pi r square. 5 by 6 times of pi r square. This is the, don't tell, because this is 1/6, that will be something called 1/5. Not like that. You have to subtract and check. 5 by 6 of pi r square. This is the area of the major sector. Once you get the minor sector area, from full circle, subtract the minor sector area to get the major sector area. This portion, this way you have to follow the problem. Now we'll do one more problem here. For example, you know that this angle in radians, you know this angle in radians, say pi by 2 radians. Pi by 2 radians. Then don't use that formula, you can use this one. So area is equal to half r square theta in radians. So half r square, radians is pi by 2. So it comes out to be pi r square by 4. That is nothing but 1/4. 90 degrees is nothing but pi by 2. 1/4 we got it. Now major sector you want pi r square minus pi r square by 4. 4 ones are 4 minus this. 3 by 4 pi r square. So this is the area of the minor sector. This is the area of the major sector. And without a mention, if they ask sector, without mentioning whether it is minor or major, then you find minor sector. Sector itself is minor sector. And if they clearly mention find major sector, then find full area minus minor sector area. Yes students, now we are doing area of the segment. First we have to draw a segment. For that you have to first draw a circle. Yeah, I have drawn a circle. I don't know whether from your camera point of view it's looking like circle or not. Okay, I chop off some portion and I want area of this portion. This is your minor segment, whereas the remaining portion of the circle is called major segment. I draw from here to the end of the circle, which I call it as radius. From here to the end of the circle I call radius. I can chop here or here or here or anywhere I can chop. Therefore, I cannot write this also equal to r. Many students in the beginning they may confuse thinking that this is r, obviously this is r. I can cut anywhere. For example, I have a circle like this, I cut it here. Then do you think that this r and this r and this are same? They are not. So don't think that it's an equilateral triangle. It's a triangle, but it's not equilateral triangle. So for example, this total angle I take it out to be theta in degrees or radians, whatever it may be. I draw a perpendicular drop like this, 90 degrees, such that one single triangle I break into two right angle triangles. Previous one is not, I don't know, this angle, any one of them 90 or not, I don't know. Now I confirm because I dropped a perpendicular. So this angle becomes half of theta, that is theta by 2. This angle becomes half of theta, that is theta by 2. So now I have to find out the area of this triangle and add it to this triangle. Why I am doing all these things? Because I know how to find the area of a sector. From that sector, if I remove this triangle, I get segment. So this is a sector. This is a triangle. This triangle I remove it. Then I left over with segment. So to find area of a segment, I should know how to find area of a sector. From that subtract area of the triangle. And now furthermore, if you happen to learn trigonometry such that this length is unknown to me, this angle is theta by 2, this length is known to me r, in that way triangle is there. Then you know triangle area is half into base into height. So this is base, this is height. If this is hypotenuse, this is opposite and this is adjacent. Opposite is hypotenuse times of sine theta. Adjacent is hypotenuse times of cos theta. So, you know hypotenuse. What is hypotenuse? R. What is cos of theta? Here is only theta by 2. I got adjacent. Similarly, hypotenuse is what? R. Sine theta by 2. So, I know base of the triangle, height of the triangle. I can use half into base into height. So, area of triangle is equal to half into base into height. Half into base is r cos theta by 2. Height is r sine theta by 2. Don't worry about theta by 2 things, we will understand it later on. But this kind of triangle, we have one here and one below. That also I have to include. So, two areas. So, whole bracket into 2. Whole bracket into 2. So, this 2 and this 2 you can cancel it off. Or you can remember like that. There is another formula in trigonometry which is helpful if you know it. 2 sine theta cos theta is equal to sine 2 theta. This comes in intermediate trigonometry. But if you can learn one formula, lot of headaches will get reduced. So, instead of that, now what you have? 2 times of, we have here r and r square by 2 in times of this. So, 2 sine theta by 2 cos theta by 2 is there. That can be written as sine times of 2 times of the inner angle theta by 2. 2 gets cancel, you will get sine theta. Full angles you take, double angle you will get. Half angles you get, take double half you get it. That is 1. So, using this formula, what you can do is r2 r square by 2, keep it aside. This 2 outside whatever we multiplied for the two triangles, you can take that into account. So, 2 sine theta by 2 cos theta by 2. If you cancel off again, we have to multiply 2 because in the formula there is 2 sine theta cos theta. Half this 1 by 2 r square 2 sine theta by 2 cos theta by 2 can be written as sine theta. Half r square sine theta. That is the area of this total triangle. This half triangle plus this half triangle is the total triangle's area we have found out. Now, take a snapshot. Remember them. Now we are going to the conclusion. Now, area of minor segment is equal to area of minor sector minus area of triangle. So, area of minor sector, I told you, half r square theta in radian minus area of the triangle. Now you got half r square sine theta. This is the formula. Area of segment. But what if angle is in degrees? What if angle is in degrees? So, write in degrees. Half r square theta in radian can be written as theta in degrees into 2 pi by 360 degrees. Degrees. So, if it is 360 degrees, 360 by 360 goes 2 gets cancelled, pi r square will get back, full area, minus half r square sine theta in degrees you substitute here also. Then you get segment area. See here, I'll tell you one thing, even though it's not given in textbook how to, the second part is not given in textbook, conversions. But if you learn conversions, it's a big advantage to you because you can convert radians into degrees and degrees into radians, and whenever you, whichever formula is easy to you, that you can remember it. So sometimes formulas are easy. So here you can see area of minor sector easy to remember, half r square theta in radian mode, and other one is half r square sine theta. This kind of things in future you will find it more comfortable once you know formulas in radians. So unit conversion from radians to degrees, degrees to radians. In this way we have completed finding length of arc, finding area of sector, finding area of segment. So quickly, segment is already written on the board. I am not changing that. How to find area of sector? This is area of sector. And how to find length of arc? Length of arc is equal to radius times theta in radian, or radius times theta in degrees into 2 pi by 360. Similarly, area of sector is this formula, half r square theta in radians, or which is also equal to half r square theta, you write it in degrees, multiply by 2 pi by 360. You will get the answer in square centimeters or square meters. Whatever r square you have taken, that will take care of. But this conversions you remember, and original formulas you remember. Similarly, once you know these things, how to find segment area, you know it. Next, sometimes they may ask you to find area of the major segment. Suppose we have a circle like this. This portion is minor segment. This portion is major segment. So what you do? Area of the minor sector, you find it. Area of the minor sector. You can find area of the major sector otherwise. What to do for this? We don't want minor segment area. So first to find minor segment area, subtract from full area of the circle. Subtract from full area of the circle. That will take care of finding area of major segment. But you should be conscious what they ask. Did they ask minor segment or major segment? Generally segment means minor segment. Generally sector means minor sector. Arc means the small one, not the longer one, because if you go from one portion to other portion of circle, that small portion is called arc. The other part can be called as major arc, minor arc. Major sector, minor sector. Major segment, minor segment. So three things: arc, sector, segment. You should be able to find arc, sector, segment. For this, you should know terms, first thing. Second thing, you should know conversions. Yes, students, let us try a simple problem. So 4 circles are been given, the square of side 12 cm. So they want the area of the shaded portion. Area of the shaded portion, this portion. So from the square, if I remove 4 circles, I get the shaded portion. So shaded portion is equal to square area minus 4 times of circle areas. So square area, square formula you should know, side into side, 12 cm into 12 cm, side into side, minus 4 times of area of a circle, pi into r square. What is the radius? See, out of the 12, half is up to here, that is the diameter of the circle. So up to here only we should take. So from 12 make it half, that becomes 1 circle, and half of it, that is 3 cm. 12 lo half is 6, 6 lo half is 3. So pi into 3 square. Remaining is all simplification. So 144 centimeter square minus 4 into pi square, you will get the area of the shaded portion. Calculation you have to do it. Yes, now they asked some other question. They are given 4 circles and there is a square inside. Previously it was outside. Now they are asking the shaded portion, only this much of portion. This and this are not included in it. So 7 centimeters means this will be 3.5, 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 like that. So all the radii are known. So this is 1/4 of a circle, this is another quarter of a circle, this is another quarter of a circle, this is another quarter of a circle. Like that 4 quarters are there. So 4 quarters if you mix, you will get 1 full circle. So 1 full square area means minus 1 square. For example, we have redraw the square. This way you plan it, otherwise you have to find segment sector areas and you have to add it and do with long calculation. So what you do is you span up with a circle like this. So this portion is nothing but a small part of it, like this much, like this much is here. Next, this portion is here, this portion is here. So all these four portions are making out. So it is nothing but area of square minus area of circle, that is 7 square minus pi into radius 3.5 whole square, pi r square. That is a shaded portion. If at all you don't redraw it like this, the problem will be more complicated. First you have to find area of the square, then you have to find area of sector, and 4 sectors you have to add it and get it. So 4 sector addition is also coming out to be circle, but should be able to take the given shape and visualize it in some other form so that you can do the calculations. That's what is called areas related to circles. Sometimes they say that in archery, concentric circles they give. This is one circle, next one circle, next one circle, next another circle. This is black, this is red, this is yellow, this is blue. So these strips are been given and they give this distance to be 10 cm. Next, radius of the next one is 12 cm. Radius of the third one is 15 cm. Radius of the fourth one is 20 cm. Like that they are given. Now they ask you to find the each strip area, blue strip area, yellow strip area, red strip area, black strip area. How to find out? First you take the blue strip area, that is full area, including everything, minus this the inner portion. So pi, radius of the blue strip is 20 square, minus pi, radius of the yellow strip is up to here, it is 15 cm, 15 square. You get the area of the blue strip. So you can find area of the bigger circle, mali area of the inner circle, then find the area of the inner circle, then find the area of the inner circle. This area minus this will give you blue strip, yellow minus the remaining will give you red, red minus black will give you, red circle minus black circle will give you total, minus black will give you red strip. Similarly, left over is black circle. Like that you can find it out. This is another problem. They say that there is a square field and one horse is tied like this, and this field area is 100 meters or 10 meters. Length is 10 meters, side, and this is horse is tied by 7 cm long thread, long rope. So up to 7 cm becomes the radius for it. So 7 cm, 7 cm, 7 cm. So it will graze up 7 cm quarter of the grass there, leftover grass you want. Then take square minus this segment area. Square area, you know, 10 into 10 minus this portion of the area is 1/4 of the circle of radius 7 cm, because it is not full circle. 1/4 of circle of 7 cm. So same question if they ask some other place. Say they say that it is tied here and this is 7 cm. How much it will graze? So it can go here up to 7. Here also it can go up to 7, but there is no grass. So you have to create a D shape. Here no grass. Here no grass. So the remaining portion you have to calculate it. That becomes little lengthy, but you can make out this kind of questions on your own, and you can, whatever textbook questions are there, more than that you can find it out. That is what is areas related to circle. See, the basic theory what is required is first you should know what is length, what is arc, and you should be able to find its length. What is sector, you should be able to find its area. What is segment, you should be able to find out its area. Once you do this portion clearly, remaining is see the question, visualize it, and try to create your own answers. This can be even visualized for 3 dimensions and more also. So this kind of questions will be there. Yes, see here, this is another question. Find the area of the shaded portion they ask, and they are told that this is trisected, means this distance and this distance are equal, and nothing is been told more than that. Trisected, you can take any length, so we only take 15 cm, so this is 5 cm, this is 5 cm, this is 5 cm, you can take like that. Then how to find the area of the shaded portion? What I do is, I lift this from here and I put it here, so I'll get one full portion. Because empty portion I brought it here, this portion I shade it up. This portion I remove it and I put it here. Like that you make a plan and get the answer. So what is to be removed from what? Just check. I made some mistake. I'll rectify it. 1 second. Yes, students, we are revisiting the same problem. Just this portion which is empty, I lift it here and keep it here. This half big circle of 10 centimeters diameter, I put it here. So this portion I remove it, and this one I also removed, whatever I removed. So this is the leftover portion. So what to do? How to get it? Area of the big circle minus area of this circle plus area of this circle. Then leftover shaded portion you get. Shaded portion is equal to first bigger circle, pi into 15 whole square centimeters, because that is 15 centimeters. So we got the circle, bigger circle area. From that, this portion you have to remove it, minus pi into 10 square. But this portion only we want, we don't want this portion. This portion is to be included into this. So plus pi into 5 square. So in all of them, pi common. 15 square 225 minus 10 square 100 minus 5 square 25. 225 minus 25 is, sorry, plus it is 250 minus 100 150. So pi into 150 centimeter square. That will be the area of the shaded portion. Only thing is you have to visualize one given shape into some other format, then you can get everything. You try as many problems as you can. We'll stop it here.